Federated Identity Management, or FIM, is a key component of the CISSP certification course focused on Domain 5, Identity and Access Management, IAM. FIM allows for the sharing of identity information across domains, which facilitates seamless access to resources and services. By implementing FIM, organizations can enhance user experience, improve security, and streamline access management processes. In this section, we're discussing Federated Identity Management, FIM, in detail. First, let's understand what FIM is. Federated Identity Management allows users to use the same login credentials across different organizations or domains. The key components of FIM include identity providers, IdPs, and service providers, SPs. IdPs authenticate users and manage their attributes, while SPs validate these users and authorize access to services based on their roles. We also have specific standards and protocols such as SAML, OAuth, and OpenID Connect that ensure different systems can work together seamlessly. The importance of FIM cannot be overstated. It enhances user experience by reducing the number of logins required and simplifies access management. Additionally, it improves security by adhering to standardized methods for authentication and authorization. Let's jump into the key components of Federated Identity Management, FIM. FIM consists of three main elements: identity providers, IdPs, service providers, SPs, and federation standards. First, identity providers play a foundational role. They are responsible for defining and managing user attributes, such as usernames, roles, and permissions. IdPs also handle the process of authenticating users, ensuring that the individuals accessing the system are who they say they are. Next, we have service providers, or SPs. SPs validate and authorize users based on the credentials and attributes provided by the IdPs. After validation, they offer various services to the users according to their roles and permissions within the organization or network. Lastly, federation standards are essential for ensuring interoperability among different systems. Some of the prominent standards include SAML, Security Assertion Markup Language, OAuth, and OpenID Connect. These standards facilitate secure and effective communication between IdPs and SPs, making the federated identity system robust and scalable. Together, these components create a cohesive FIM system, enhancing user experience, improving security, and streamlining access management. Here, we're focusing on the standards and protocols that are fundamental to federated identity management. First, we have SAML, or Security Assertion Markup Language. This is an XML-based protocol specifically designed for the exchange of authentication and authorization data. One common use case for SAML is enabling single sign-on (SSO), which allows users to authenticate once and gain access to various services without needing to log in multiple times. Next, we have OAuth. This open standard is an authorization protocol which enables third-party applications to obtain limited access to user accounts. For instance, you might grant a website permission to access your profile information on another site without sharing your password. Lastly, there's OpenID Connect, which is built on top of OAuth 2.0. While OAuth focuses on authorization, OpenID Connect adds authentication capabilities. A practical use case would be the Login with Google or Login with Facebook features, providing a seamless way for users to log into different services using their existing credentials from these platforms. These protocols ensure secure and efficient handling of authentication and authorization across various systems and applications. Now let's cover the implementation of SAML. When implementing SAML, we need to understand two key components: the identity provider, or IdP, and the service provider, or SP. The IdP, such as Okta or ADFS, is responsible for managing user identities. The SP, like Salesforce or AWS, provides various services that the user wants to access. Here's a typical SAML flow. 1. The user attempts to access a service provided by the SP. 2. The SP redirects this request to the IdP. 3. The IdP then authenticates the user and generates a SAML assertion. 4. This SAML assertion is sent back to the SP. 5. Finally, the SP grants access to the user based on the received SAML assertion. In practical terms, you might see commands and XML tags such as SAML authn request for authentication requests, and SAML assertion for the assertions that communicate the authentication and authorization details. Understanding these components and flows is pivotal to securely managing authentication and authorization processes in your applications. In this slide, we'll be looking at the key components and flow of OAuth. Let's start with the components involved. Resource owner. This is the user who owns the data or resource. Client. This is the application that requests access to the resource on behalf of the user. Authorization server. This server is responsible for issuing tokens to the client upon successful authentication. Resource server. This server hosts the resource that the client wants to access. Now let's go through the OAuth flow. 1. User authorizes client. The user gives permission to the client to access their resource. 2. Client requests token. The client then requests an access token from the authorization server. 3. Authorization server issues token. If the user's authorization is valid, the authorization server issues an access token. 4. Client accesses resource using token. The client uses this token to access the resource from the resource server. Here is a command example to illustrate the token request step. Bash curl x post d client ID equals client ID and client secret heeks and grant type authorization code h2auth.server.com/token. This command demonstrates how the client communicates with the authorization server to obtain an access token by providing the client ID, client secret, and grant type. Understanding these components and the flow is essential for implementing OAuth in your applications. Implementing OpenID Connect builds upon the concepts we've discussed previously with OAuth 2.0. Like OAuth, OpenID Connect involves several key components: the resource owner, client, authorization server, and resource server. However, OpenID Connect extends OAuth 2.0 by adding an ID token, which is used for authentication purposes. In the OpenID Connect flow, the process is similar to the OAuth flow, but with an additional step for the ID token. This ID token ensures user authentication by confirming the user's identity. Here are some practical commands to illustrate this flow. To request a token, use shell curl x post d client ID equals and client secret and grant type of code HTTPS auth.server.token. To access a resource with the ID token, shell curl h authorization bearer ID token /api.resource.com/userinfo. These commands help to facilitate the authentication and authorization process, ensuring secure access to your resources. For implementing Federated Identity Management (FIM), it's vital to choose effective tools to ensure seamless authentication and authorization. Two notable tools are Okta and Auth0. Okta is a cloud-based identity provider, IdP, that offers single sign-on, SSO, and user management. It simplifies the user authentication process and allows administrators to centrally manage user identities and access to resources. Auth0, on the other hand, is a flexible and extensible authentication and authorization platform. It provides robust features to customize authentication for various applications and user credentials, making it a versatile solution for different security needs. Here are a couple of command examples for these tools. Using Okta, execute the command Okta login to start a session with Okta. Using Auth0, use the command Auth0 deploy to initiate deployment within the Auth0 platform. With these tools, you can efficiently manage authentication and authorization processes, supporting secure and streamlined access across your applications. In this slide, we will explore real-world scenarios to understand the application of identity management solutions. Scenario 1 is about implementing single sign-on, SSO. The challenge here is that organizations often have diverse applications requiring separate logins, making user management cumbersome. The solution is to use SAML, Security Assertion Markup Language, which enables SSO across different applications, simplifying the login process and enhancing user experience. Scenario 2 addresses third-party access. The challenge is to securely share data with partners without compromising security. The solution is employing OAuth, which allows you to manage and grant scoped access, ensuring that partners receive only the necessary data while maintaining strict security controls. These scenarios illustrate how identity management solutions be applied to solve real-life challenges, focusing on improving security and user experience. To successfully implement Federated Identity Management (FIM), it's essential to follow best practices, which can be categorized into three main areas: security, user experience, and interoperability. Starting with security, always use strong encryption for token exchanges to protect data. Regular audits and compliance reviews are necessary to ensure ongoing protection and adherence to standards. In terms of user experience, simplifying login flows with single sign-on (SSO) significantly enhances usability. It's also important to maintain transparency about consent and data sharing to build and retain user trust. For interoperability, adhering to standards such as SAML, OAuth, and OpenID Connect guarantees seamless integration across different systems. Ensuring compatibility among various vendors will minimize integration issues and foster a cohesive identity management environment. By focusing on these best practices, you can create a robust and user-friendly FIM system that is both secure and versatile. In this slide, we wrap up our discussion on Federated Identity Management (FIM) by summarizing its key benefits and providing some closing thoughts. FIM significantly improves security, enhances user experience, and streamlines management processes across various platforms. To successfully integrate FIM, it's essential to have a solid understanding of the relevant protocols and standards. Regular updates and reviews of FIM implementations ensure they remain effective and secure, while staying informed about emerging standards and protocols helps keep your system up to date and compliant. For next steps, I recommend engaging in hands-on labs and exploring real-world case studies to deepen your practical understanding. Additionally, consider further readings on advanced identity and access management topics to expand your knowledge. Thank you for following this course on Federated Identity Management. In this slide, we provide you with references and further readings to deepen your understanding of Federated Identity Management (FIM) concepts. For further reading, you can explore Understanding SAML and OAuth 2.0, Getting Started in API Security. Both sources offer comprehensive insights into some of the key protocols used in FIM. We have also included documentation links for tools such as Okta and Auth0, which are industry leaders in identity and access management. These links will guide you through the commands and tools essential for practical implementations. Lastly, we have cited the official CISSP study guide and the NIST special publication on access control, which are invaluable resources for anyone serious about mastering access control and identity management. These sources will give you a solid foundation and keep you updated on the latest standards and practices in the industry.